Hey class, this is more about, there we go. This is more about sheet 9, which is what we call predicting products. So I just want to take it back to this. You guys have seen this before, definitely for sheet 8 and previously. Types of reactions, of course, is single displacement, element plus an element. How do we know if it's an element? It's an element because of one single capital letter, such as something like, I don't know, AG plus BR2, something like that. Each one of those has one capital letter and only one, and the plus sign then separates the two. Compounds are more than one capital letter, so you can have something like KClO3. It can be plus heat, but it doesn't have to be. It can just be something like CaCO3 and then the arrow. Okay, so sometimes it can be plus heat and sometimes it doesn't have to be, but it's just a compound and then the arrow and no plus sign. That's another big indicator. That's for decomposition. For single displacement, I have an element plus a compound, and for double displacement, I have a compound plus a compound. So let's take a look at what we got here. Let's go through the first four, only identifying first, and then I'll show you a couple examples. So for the first one here, I have a capital letter and a capital letter and a capital letter. So it's three capital letters. This is definitely a compound. The positive part is for A is PB, and the negative part is B. NO3 is B. And then Na is C, and CrO4 is D. Okay, so the polyatomic ions I notice here are the negative parts, which is pretty typical. On the other side, we check to see if this works. I put together A and D and C and B like that. Okay, so what I'm looking at here is a compound plus a compound, so this is a double displacement reaction. I'll finish this before I finish the screencast. So let's take a look at number 2. Here I have anything plus heat is automatically going to be a decomposition. What kind of decomposition? This is going to be a hydroxide decomposition, which is one of the first ones that we went over. So here's another plus heat, so of course this is going to be a decomposition. What kind of decomposition? This is a nitrate decomposition. So this is going to be definitely a reaction because all nitrates decompose. Number 4, I have an element, copper, plus, and then HgNO3 2. So this is definitely an element plus a compound, so this is a single displacement. And then I have to check to see what I have for numbers to see if this is actually going to work. And it looks like this one is going to work. So let's take a look at numbers 1. Let's do 1 and 3. So 1 and 3. So I've already started number 1. When I go from the left-hand side and I have PB as a plus 2 because of that 2 there, and that's all because nitrate's a minus 1, which means that PB must be a plus 2. I have to go back to symbols and charges. The D is CrO4. If you know anything about chromate, you know that that's a minus 2. So CrO4 with a minus 2 like this, I get rid of, so I crisscross, and because it's a plus 2 and a minus 2, I don't have to change anything. PbCrO4 is fine. So I take a look at the next part. The next part is Na. I drop the subscript. I drop this subscript when I go from left-hand side to right-hand side because I have to make new ones. So that's Na with a plus, and then NO3 has a minus 1. So now I go back to crisscross, which in this case just means I cancel them out like that. And now I check to see. I check to see if there is a solid that we've produced. This is a double displacement reaction. This is not an acid base because there's no H in front, there's no OH after. So that means we're looking for a solid. That means you flip back to the solubility chart on the test equation sheet that I have attached to this. You look for PB, you look for CrO4, and you will notice that it says solid there. Okay, now this is always going to be an aqueous because all sodium compounds are aqueous and all nitrate compounds are aqueous. So here's our solid. You can put the S there or you can put an arrow pointing down. Either one is fine. That means it's a solid. That means this works. And then we go ahead and balance the equation. 1 PB, 1 PB. Two NO3s, I only have one over here because there's no parentheses, and I put a 2 in front to get 2. That means I have 2 NAs. Over here I have 2, so that also works out. 1 CrO4 and 1 CrO4. So all I have is a 1, 1, 1, 2. So let's take a look at number 3. Number 3 is a nitrate. So for the nitrate, it's actually pretty simple. This is not an alkali nitrate, not a group 1 metal nitrate, which means that it's not simple. It's actually got flip. If you want to, you can flip to the notes. You can see what it is. So if it's not a group 1 metal nitrate, that means you get nitrogen dioxide plus oxygen plus the metal oxide. Okay, not barium. This is, yeah, it is barium. Oh, I was right. So this is barium. Barium has a +2. And this is oxide, it's the metal oxide, so that gives us bonehead, that gives us a -2, like this, and because it's a +2 and -2, I can cancel them out, and then all I have to worry about is balancing the equation. So here I have 2 nitrogens and 6 oxygens. If you remember this, you notice that there's only 1 oxygen down here. If I double that, because I have an even number on the left-hand side, and then I double the one that's odd, that gives me 2 bariums. So that means I double the whole thing. That gives me 4 nitrogens, and that gives me 12 oxygens. So here I have 4 nitrogens, which gives me 8 oxygens plus another 2 equals 12. So that actually now is balanced. So I got 2, 4, 1, 2. And it looks like all the other nitrate decompositions that we've done. Okay, good luck. Please ask questions.